Okay, fifth graders, so tonight's homework. If this is the whole, I know it's hard to read, but it does say whole in there. And you can see that this is 1/5, so we've got 1/5, 2/5, 3/5. And the question is, if we broke these fifths instead into tenths, how many tenths would that be? What's equal to 3/10? Or I'm sorry, 2 3/5. And we can count up 1, 2, 3, 4, 5, 6. 6/10 is equal to 3/5. And this is similar to what we were talking about the last couple of days, where we can multiply this by 1. It's actually a 1 because 2 over 2 is the same as 1, and that's our identity property. We're going to get the same number back. 3 times 2 is 6, 5 times 2 is 10, and we can see that those are equal also. Just another way to do it. This one's got a nice picture for us again. You can see this is 1/3, and this is 2/3 of the whole. So if we want to break those thirds up into twelfths instead, you can see each piece is broken up into 4. So let's count 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12. 8/12 is the same as 2/3. This one, we've got 1/4, and it's asking eighths. So if I break my fourth up into 2, then I can call those eighths. We noticed today that if we split one of our fractions in half, that the denominator doubles, and that's exactly what happened here. So if we count it up, 2/8 is the same as 1/4. This one, we're supposed to color 3/4 of the shape, and we're going to have to look at this differently, because if we count each square, it's going to be a little, it's going to give us eighths instead, and we want fourths. So let's look at it this way. There's a fourth, 2/4, 3/4. So I've got a group of 1 here, and I've got a group of 2, and a group of 3. So that's one way you could do it. You could also leave this one blank and color the other 3. It's up to you. The next one, we have to color 3/4 of this shape. This one's broken into thirds this way, but if I look at it this way, I can see my fourths, because we want it broken into 4, because our denominator is 4. So we're going to shade in 3 out of these 4. And then over here, it's broken into, looks like 8 equal pieces. So if we want to do 3/4, let's break it into 4 equal groups and shade in 3 groups. Okay, let's do, well, I didn't know if this would help us down here. It might not. Write 3 equivalent fractions for each of the shaded illustrations. So this one I can see 2 out of, let's see, 1, 2, 3, 4, 5, 6. 2 out of 6 are shaded. And a different way that I could do that, instead I could break it into 3 equal pieces if I wanted to. I could say this is, let's see, well, maybe I'll break it this way instead. This is a third, and this is a third. So I could say that this is 1/3, and this is, so this would be 1 out of 3 if I want to do it that way. And another equivalent fraction, I could break it up differently. Well, we've got 2, 6, 1/3. Maybe you want to break all of these in half. And we already know if we break them in half, we're going to get 12ths. But I could actually count them if I wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now, when I broke it into 12ths, now I have 4 that are shaded. So 2/6 is equal to 1/3, which is equal to 4/12. Over here, we're going to count how many are shaded. 4, 8 are shaded out of, that looks like 12 possible. We could rearrange those differently. Let's count these as groups of 3. And now I could say 2 out of 3 are shaded. How else could I do it? I'm going to think about that and come back. This one, I'm going to count this as 1 out of 2, half. I could change this and make it into fourths, and now I could say 2 out of 4 are shaded. And I could do it again if I wanted to, or I could have broken it into thirds. Let's try that. Break it into thirds, and now I've got 6 equal groups. And when I do that, I've got 3 6. Still thinking about that one. This one I told you is optional. Not all of them are, but that bottom portion is optional if you are choosing to do it with me. Simplest form means it can't be reduced anymore. 1/4 is in simplest form. It cannot be reduced. This one is not. I could divide them just as I could multiply them by 2/2. I can do the same thing with my identity property. I could divide them by another number, such as 2/2, which we know is the same as 1, and I could get 3/4. Now that would be simplest form because it could not be reduced anymore. 6/12 we know is the same as 1/2. That is not simplest form. 2/3 is simplest form. Can't reduce it any longer or anymore. This one is not simplest form. I could reduce this. I could divide them both by 2/2, and I could come up with 2/5 on that one. So it is not simplest form. 5/8, however, is, because I can't divide it by any number that's the same on the top and the bottom. I could divide this by 2, but I cannot divide 5 by 2 evenly. So 5/8 is in simplest form. And back to this one. This one is gonna haunt me. Let's see.